and I'm giving a talk on obesity in colonised populations, the gene-environmental mismatch. So I just want to first off acknowledge that I'm from Australia, which is, you all know Australia in the South Pacific, and I want to acknowledge that the traditional owners of the land of Australia were the Australian Aboriginal and Torres Strait Islander peoples, which was a diverse mix, or a diverse number of Aboriginal and Torres Strait Islander tribes and nations within the one country, all with different languages, cultures, and lifestyles. So that was the first thing I want to acknowledge, and that their elders, and acknowledge their elders past, present, and future. So Australia always was and always will be Aboriginal land. Sovereignty was never ceded, and they came out of Africa 50 to 80,000 years ago. And they're the oldest continuous civilization in the world. So there were up to 1 million people by the time of European invasion in 1788. And the types of food across the large number, 30, 40 number of nations, the types of food acquisition methods was hunter-gatherer, agricultural and aquaculture, which is fisheries. They had sophisticated hunting techniques, which included weapons such as boomerangs, which included fishing. They would also go into the wild, and they would know which fruits and nuts and tubers were toxic, and then they would have multiple steps to detoxify them. They would soak them, then they would bury them in the soil for 3 months, and then they would come back and they would grind them, and by that stage all the toxins had leached out of it, and then they would use that to make various foods and bread. So lots of sophisticated techniques. And that was called, we now call that bush tucker. So this is the map of all the different Aboriginal nations within Australia. So you can see the huge diversity. When you're in a country for 80,000 years, you're going to have a large number of languages, a large number of cultures, a large number of lifestyles, a large number of tribes, and so therefore in Australia, over 80,000 years, we had such a very large number of nations and tribes. And there was no diabetes on European arrival. So they were a healthy, thriving, lean and fit people. Obviously, many of their dances were them reenacting or rehearsing the hunting methods. It was a way of passing on the teaching to the youngers, and we always use dance and culture and singing and art to reflect our worlds. So their world was the earth and the nature, and so many of their dances and many of their songs and music and art represented the natural world around them, which was everything to them, their grocery store, their pharmaceutical store, as you can understand. And then a very, very sad state of affairs then emerged when Europeans came. And you can see that these dignified, cultured people who had survived for 80,000 years were chained up and starved and tortured and killed in mass numbers. And this is a white oppressor treating these Aboriginal people in this fashion. They also made it illegal to speak their language. They made it illegal for them to hunt and gather in their own lands. They rounded up Aboriginal people and they shot them, and any resistance was met with a quick, violent overthrow of the group trying to resist them. And the big issue, a very big issue, has been alcohol was introduced, and alcoholism has become a very, very problematic toxin in the current Aboriginal diet and lifestyle issues of some communities. So the Europeans labelled Australia terra nullius. That means an empty country with no people. And the way they did that is they classified Aboriginal people as part of the flora and fauna, meaning part of the animals. So they were not humans, they were just animals to be conquered. And so there was genocide. And Aboriginal people were often rounded up into town camps. They were displaced from their homelands and thrown into these town camps, removed from their own ways of hunting. And 80,000 years, if you ever go to Australia or see pictures of it, such a rugged climate, very sophisticated, evolved and developed techniques of living were ripped from them. They were thrown into town camps and given sugar and bread to eat. Palm Island was an island where I showed you all the different nations. People from a whole bunch of different nations were just dumped on this island. So there's going to be conflict, of course, because, you know, these are not people who naturally had been living together, you know, on the mainland. So that became a kind of a bit of a problem initially, but Aboriginal people have come together, and Palm Island is now something that they have developed to be something they're very proud of. And there was no citizen status for Aboriginal people until 1969. Then in the 1950s and 60s, there was this terrible situation called the Stolen Generation, where if you were what they called half caste, if you were half Aboriginal and half white, then the white police would come and kidnap you from your families and put you into orphanages and foster homes in order to raise you up to be maids and servants for the Europeans. So there are still people now who recall being stolen from their families, and there are still mothers who recall their children being stolen from them. So that was the Stolen Generation, and there's many stories and films about they coming, they would hide them under beds, hide them in cupboards to try and prevent them being stolen, because it was considered if you were fairer skinned because you were half caste, then you were better being taken away from your Aboriginal families. And they were removed from the national parks, and their land was renamed national parks, where they were no longer allowed to hunt and gather. And so Homo sapiens sapiens was the apex species in the food chain. You remove humans from the food chain, the whole ecology of that food chain becomes disrupted. So when you think about a species that's been somewhere for 80,000 years, they're going to be an integral part of the ecology of that food chain. So saying, oh, we're a native park now, people aren't allowed to hunt anymore, what's happened is it's become this incredible overgrowth of certain species, such as pythons, because pythons was a food source for Aboriginal people. And so pythons are killing the native marsupials because the food chain's been disrupted. So we now have issues with marsupials becoming extinct because of overgrowth of pythons, because Aboriginal people aren't allowed to hunt their traditional food. Is this making sense? So on Australia Day, or Invasion Day, once a year, Aboriginal people do, and their allies, remind the rest of us that sovereignty was never ceded, and that's the Aboriginal flag. So there's, unfortunately, as a result of all of these things, you can imagine what the health outcomes were for Aboriginal people. So in 2006, health bodies and human rights organisations and NGOs resolved to achieve health and life equation equality for Australia's Aboriginal and Torres Strait Islander peoples, and they wanted to achieve life expectancy equality by 2030. But unfortunately in 2017 the gap's widening because there's gains in the non-Indigenous population but no real gains in the Indigenous population. And this is called Closing the Gap campaign. So by 2010-2012, life expectancy is still 10 years lower for Indigenous than non-Indigenous people, and 65% of Indigenous deaths are under the age of 65, compared to only 20% of non-Indigenous deaths. So in the Closing the Gap Prime Minister's report in 2017, there were only 2 tangential references to obesity and 31 references to smoking. And obesity, as we all know, is the core risk factor for diabetes mellitus, end-stage renal failure, and cardiac disease. So this is data that I have, as part of a paper that I'm preparing for publication, this is data that I have collated from various sources to develop some relative risk estimates of various conditions in Aboriginal versus non-Aboriginal people. So the relative risk of diabetes mellitus if you're an Aboriginal and Torres Strait Islander person is 4, obesity 2.45, and cardiac disease 2, and renal disease 4.43. So in the 2004-2005 National Aboriginal and Torres Strait Islander Health Survey, 29% of Aboriginal Australians are obese versus 17% of other Australians. And Torres Strait Islanders, 86% are either overweight or obese. So if you compare Aboriginal people and Indian people, such as myself, have a very similar physiology, which is why I became interested, because when I started to research my own physiology, then I became interested in the whole topic, and then I realised there was a lot of parallels. So if you compare to First Canadians, Aboriginal Australian people have a lower BMI for a given waist-hip ratio. What does that mean? That in Aboriginal people, the body mass index, which is an index of weight and height, underestimates the amount of fat, because waist-hip ratio is a marker of fat, okay? So also, even for a lower BMI, Aboriginal Australian people have higher cardiovascular risk factors, lipids, CRP, homocysteine levels. So BMI is not a very helpful indicator of the health status of Aboriginal people, because it underestimates the amount of fat and underestimates their cardiovascular risk factors. In Aboriginal Australians, waist-hip ratio, which is the ratio of the measurement around the hip to the measurement around the waist, and the bigger your waist, the more fat you put on in your waist, in your midsection, the larger the waist-hip ratio. So a larger waist-hip ratio more strongly correlates to diabetes and cardiovascular disease than BMI. And it also is associated with a higher HbA1c versus First Canadians, who BMI is more reliable for a risk of HbA1c. What is HbA1c? Glycosylated hemoglobin, or a marker of pre-diabetes or diabetes. So it can be very tricky to figure out what the causes of obesity are. So now moving to a broader discussion, and then I'll bring it back to Aboriginal people. So some case control studies elicit no difference. When they compare the calories and macronutrients between thin and fat people, they actually elicit no difference. That people are eating the same as fat people. And that strongly suggests that it's genes that determine whether you're thin or fat. If calories are the same and macronutrient ratios are the same, it must be genes. Genes can mediate insulin resistance, leptin resistance, hypothalamic set points. I started to make a point and then forgot the rest of the point, but cortisol is one of those hypothalamic set point mediators. And various triggers in the gastrointestinal tract to mediate satiety or fullness, hormones such as CCK, etc. So those genes can mediate all of that. So you might say insulin, it's just some genes, it's my insulin, my leptin, my hypothalamic set point, how my gut responds to food. However, case-controlled studies cannot establish causality of a ubiquitous exposure. If everyone's exposed to that exposure, a case-control study can't elicit its causality. A case-control study requires heterogeneity of the exposure within the study population. A case-control study requires that particular exposure to be different between cases and controls. Make sense? So genetic differences determine susceptibility to a universal exposure, and that universal exposure's role in etiology is masked in a case-control study. So I would say genes load the gun, but the environment pulls the trigger. Okay? So I would highly recommend, if you haven't read this paper, it is the seminal public health paper. It is a very easy read, and it totally changed my whole world view on public health. It's Jeffrey Rowe's Sick Individuals and Sick Populations. And, they did a 20-year anniversary edition of that paper. It's that well, received. It's a very uncomplicated, beautifully written paper. So, sick individuals and sick populations. Jeffrey Rowe's point was, if you look at individuals, you sometimes miss the etiological factors. You've got to look at whole populations. So you look at melanoma in Queensland, Australia. And given that most studies are in Caucasian males or Caucasian females, let's just say that it is a study of Caucasian males in Queensland. And they found melanoma rates were very high, but they didn't see a difference in sun exposure between those who had melanoma and those who didn't. What would you say? Sun doesn't cause melanoma, sun doesn't cause skin cancer. Well, we all know the sun causes skin cancer. And how is that able to be more accurately delineated? It's when you compare white Caucasians in Queensland to white Caucasians in England and the United Kingdom. Then you start to see, there's different levels of sun in these two climates, and there's different levels of melanoma. Does that make sense? So within Queensland, maybe the genes that determine exactly how fair you are, or the genes that determine your cancer risk, determine whether the sun will give you cancer or not. But the role of the sun is really only able to be appreciated when you compare the United Kingdom to Queensland. Does that make sense? So there's this National Health Nutritional Surveys. Within each time point, the obese reportedly ate less calories. And so I've seen in Australia these beliefs or these pushes to put the thrifty genotype. And the thrifty genotype is a theory that individuals are exceptionally efficient in the intake or utilisation of food. So the proposed mechanism was postprandial hypoglycemia leads to postprandial means after a meal, insulin, which leads to a dip in blood sugar, which leads to reduced glycosuria and energy wastage. So by increasing your insulin, you quickly shuttle the blood sugar away from the bloodstream and you prevent it leaking out into the urine. So that's a thrifty way of making sure you preserve every calorie you eat, okay? Insulin may also drive appetite, and it also promotes carbohydrate storage as fat, because insulin is an anabolic hormone. That's why they tell bodybuilders, have a bit of, when you have your protein shake, make sure there's a bit of carbohydrate in there to push your insulin, because that'll build your muscle better, because insulin is an anabolic hormone. Insulin drives muscle building as well. So insulin resistance was selected during alternating food paucity and food abundance. So the hunter-gatherer lifestyle of many civilizations. If you imagine a food paucity, if you have got the ability during food abundance to store every calorie as fat and prevent every calorie from being wasted, then you've got some fat to draw on during a famine. Does that make sense? So now, however, these people that evolved, these genes that evolved to store every calorie, is now in an environment of persistent easy access to calories and the removal of counterbalancing famines. So hunter-gatherer populations with a rapid nutritional transition to a modern diet becomes an easy development of obesity and diabetes. So these include Indigenous Australians, First Americans, Canadians, long sea trips in Polynesians who came from Asia, who travelled through on long sea voyages and settled in the South Sea Islands. They selected for thrifty genes, for genes that were able to store calories easily, because those who didn't have those genes were probably a little bit skinnier and didn't survive those long trips. So there was a study of remote Indigenous people who had low BMIs, 13 to 19, but their fasting insulin was a bit higher than those who were urbanised and Caucasian men. Because in order to survive those remote communities, you've got to be able to store every calorie away, those remote environments, So, and this was despite levels of obesity and type 2 diabetes being lower. Why? Because even though their fasting insulin was higher, they didn't develop obesity because they had these counterbalancing famines. So the pre-invasion Aboriginal diet was lean meats such as kangaroos, tropical seafoods, high fibre nuts, roots, tubers, that's supposed to say, and berries, and alternating periods of feasts and famines. And there was there's controversy over whether meat or fibrous plant foods predominated. Okay, controversy over which of those two. And such a diet would promote a selective insulin resistance diathesis, where selective insulin resistance, so insulin resistance promotes conversion of protein into glucose because insulin is an anabolic hormone, so it's a protein building hormone. If you're insulin resistant, the opposite happens. Protein turns into glucose, gluconeogenesis. But insulin, if you coexist this insulin resistance with selective insulin sensitivity, then glucose conversion into fat, hepatic lipogenesis, is retained. So you've got insulin resistance, which keeps your blood sugar levels high, but at the same time, insulin sensitivity that promotes glucose storage into fat. And this may have evolved as a genetic advantage in the face of intermittent food availability by encouraging fat storage, even while availing the body of glucose from protein stores. So, however, the lower overall calories and the high levels of physical activity protect against type 2 diabetes. But there was a rise in the prevalence of type 2 diabetes through environmental transformation affecting diet and activity, such that overall waist-to ratios or BMI started to increase. So modern Aboriginal diets, what are modern Aboriginal diets like? Well, there was a survey in a central Aboriginal community. Carbohydrates were 50%, fat 40%, and protein 11%. Okay? Remembering that before it was meats and berries and fruits and nuts, we're now talking 27% sugars, 22% starches. A dietary intervention was staged in that community based on, in the 80s, it was the high carbohydrate diet, and carbohydrate intake increased by 54%, particularly starch, and fat and protein dropped. So, and there was a reduction in store purchases of sugar, fruit, vegetables, and an increase in bread and flour. And then in another study, a 7-week trial, they took 16 Aboriginal Australians, 10 with type 2 diabetes mellitus, and they placed them on a traditional diet, a pre-invasion diet, 50 to 80% protein, 20 to 40% fat, 5 to 33% carbs, and quite low calories. So which of these two interventions was most effective? The high complex carbohydrate diet or the traditional diet? Well, the numbers were small in the second study, and only 14 adults were studied. I think there was a nutrition rate. Weight loss was 3 to 12 kilos, fasting blood sugar halved, fasting insulin halved, triglycerides reduced, and in the non-diabetic subjects, fasting triglycerides also fell, although there were no changes in sugar or insulin. In contrast, in the first study, I said second study, but I meant the first study, the dietary intervention high carbohydrate diet, there was no change in BMI in men. BMI jumped in women, particularly the younger ones, from 25 to 30. Obesity increased by a third. Diabetes almost doubled. HDL decreased and triglyceride increased, which are poor cardiovascular risk factors. So supplanting the traditional diets with ones high in refined carbohydrates has likely been catastrophic. And there was a study by Gardner et al. At the Stanford University, a randomized controlled trial, and he's a vegetarian, of 4 different but high-profile weight loss diets. So they range from low carbohydrate, high protein and fat, to high carbohydrate, low protein and fat. They were in overweight postmenopausal women, so some extrapolability issues. And they found that the low-fat diet, they had 2 to 3% weight loss, but a low-carb diet had 6% weight loss. And this was despite no difference in reported calories consumed. The results were stratified by those who were relatively insulin resistant or relatively insulin sensitive. Now, I don't know how he determined that. There's some technical way he has as a physiologist of determining who was insulin resistant and who was insulin sensitive. It was compared to the average measure of insulin function in the participants in the diet. And those who were more insulin resistant than average were more responsive to a lower carb diet. And if you were insulin sensitive, either diet worked. Low carb, low fat diets, both worked if you were insulin sensitive. So lower carbohydrate diets also were involved in improving blood pressure, blood lipids, and especially amongst those who were insulin resistant. Whereas those on the lower carb diet, and those on the lower carb diet kept off 15 kilos, were more likely to keep off 15 kilos than those on the high carb diet. Does this make sense? So I'm going to say that insulin resistance is not a disease state, but a malleable survival trait that has enabled 70,000 continuous years of survival in hostile Australian climates. The disease state is actually the current food environment. Highly processed UFOs, or unidentified food objects, unidentifiable food objects. So rather than stigmatise someone's physiology and say you've got insulin resistance, you're prone to diabetes, you're prone to heart disease, we should say to people you have a particular genetic profile that needs to be matched with a particular environment of nutrition and physical activity in order for you to be successful. So the way forward is to keep insulin resistance beneficial and not a disease state. And the ways that, if you go back to the traditional ways Aboriginal people ate and moved, they would have periods of fasting. So you bring in some intermittent fasting into their diets. You have them fast overnight for 12 to 14 hours, no middle of the night snacks. You have a few hours between breakfast and lunch and dinner, and the mechanism is insulin receptor tachyphylaxis, where if that insulin receptor is being hit by insulin constantly because you're grazing all the time, that receptor is going to become resistant to insulin. So if you give your insulin receptors a break overnight or through the day, then that receptor stays more sensitive to insulin. Preserve muscle metabolic activity through movement, so there was lots of hunting and gathering and active lifestyles. Muscle mass has 2 metabolic advantages. Number one, it's a sink for glycogen. So if glucose is being turned into glycogen, the more muscle you have, the more glycogen you can hold. So So the carbohydrates you eat get packaged into glycogen. There's less available for conversion into fat. And secondary, the more muscle you have, the more mitochondrial activity you have. So the more you're churning through the foods you eat in order to keep that muscle metabolically, to metabolically supply that muscle, you will be using up your carbohydrates, converting them to ATP and all the mitochondria in the muscle. Higher protein and or higher fiber diets, either's actually successful. You know, you can have a diet very high in fiber, a diet very high in protein. It's what you take out, which is the processed carbs, the sugars. And telling people to approximate a traditional diet is the way forward. So by utilising and accessing their own indigenous knowledge of traditional food gathering and preparation, the solution may be re-implementing what has always worked. So you tell them, you go into a supermarket, and you can buy kangaroo meat in supermarkets these days, and you say to them, what did your mob eat? Your mob ate meat, they ate berries, they ate nuts, they ate tubers, they ate fibres, they ate vegetables. And so by encouraging people, indigenous people, to go back to how they used to eat, they can walk into a supermarket and they can choose, select those foods that approximate their own traditional knowledge. So it's no longer me, representing the invaders, coming along and telling them, we can fix you. You've got a disease state and we can fix you. Instead we go, all we can do is apologise for disrupting your traditional and healthy ways of living, moving, working, being nutritionally supplied, being active. Bring up or re-engage your traditional knowledge, and then facilitate you being able to implement that in our current environment. And there's any questions?
About the diet with the high carbohydrate, the low carbohydrate, and the protein. Because we are some experience with keto diet. The keto diet is the start of the obesity or the body mass reduction, because you need to increase the muscle mass. But if the carbohydrate is lower than 2 grams per kilogram per day, that we must calculate with them that the brain function are very significantly influenced. The people are nervous, they are not able to sleep, they are not able to concentrate, and etc. The question is, how long do you recommend to increase the protein?
Okay.
And how long to reduce the carbohydrate?
So there's the whole keto diet and whether it affects brain function or not is somewhat controversial.
Yeah.
Some people say that as you transition from mostly burning carbohydrates to mostly burning fat, there's a period in which people get headaches, in which people struggle, in which they're fatigued, in which they feel nauseated, and so tests of function obviously show that they're not functioning very well. So I would say that if they were to follow them out to 3 months, 6 months, 9 months, then as they transition into using fats as their primary fuel source, I mean, look at the Native Americans and the Native Canadians who live up in the areas where in the Arctic areas, where seal blubber, whale blubber is their main food source. I think it's about that transition to going from processing carbohydrates to processing fat is maybe a temporary thing. The second thing I would say is, I'm not going to prescribe to somebody go fat, go a high fat, high protein diet, or go a high fiber, high plant diet. It's controversial, which predominated back in those days anyway. Do you know what I mean? So some people say it's nonsense. The Paleolithic diet was not high in fat and protein. The Paleolithic diet was very, very high in fiber. When they go to African tribes and they show that they're eating double, triple, quadruple the amounts of fiber we eat, and they're eating 40, 50 different types of plants, whereas we're eating, 5 or 6. So it's controversial as to whether it's plant-based diet or a protein fat-based diet anyway, which is garnishing which. So I would say to people, look, either is fine. Either you go the high plant-based diet. What I want out of the diet is what we've brought into the diet, which is alcohol, processed sugars, processed carbs.
Exactly. It is a very important question. Because the diet must be adapted to the subject. For example, if you calculate with the muscle morphology, fibers, slow twitch, fast fibers, they need other support from diet. And I'm a little aggressive again to general recommendation for the diet.
Yeah.
Because
So am I.
you must firstly very carefully to follow, to know the all data about the subject. And mainly, do you have any chance to obtain the information about the muscle morphology? And you must compare with them that the people must be, after the changing of the diet, must be able to work, must be able to realize the job, and must be able to overlive this period of diet. And according to my opinion, the last question, what do you mean about the increase of body mass index in the Aborigine against the normal other Australian? Because they have practically twice more, twice higher the body mass index in the native population of Australia. It represents 29 per kilogram per meter quadrat against to the 17, 19 in the normal population of Australia. What do you mean the main reason why the body mass index is so high? Is it the changes in the lifestyle?
Yeah, obesity. So 29% are overweight or obese, and that number may actually underestimate because it's based on BMI. And we know that BMI underestimates, unhealthy levels of adiposity in Aboriginal people. So it could be 39, 49% versus 17%. What's the main reason? Everything that I've just presented in here. The supplanting of their traditional diets and lifestyles and their traditional economies with alcohol, processed sugar, processed starches, and a welfare dependency, because that transition from a population that was successful for 80,000 years to this civilization that's just been dumped on them has been one that's been very hard to navigate.
It will be a very interesting question, how to change the muscle contents in the bodies, the people before the intervention from Europe, and how to increase or decrease the muscle contents, and
so this is what
how to change the extracellular mass, intracellular.
100%. This is what I say. This is not what I say. First, when you talked about individualising diets, if you don't mind if I just go back to that. I've had clients, not many, but men particularly, who like a lot of meat, who are kind of tough guys, strong guys, and I give them a choice. I say you can eat however much meat and fat you like. Because meat and fat are so satiating and they trigger satiating hormones, it's kind of a natural control as to how much people eat. If you have too much protein, you actually also stimulate insulin just as much as if you have too much carbs. But people I tend to say, eat a decent amount until you're full, and lots of vegetables, but get your carbs right down. The Atkins, the high fat, low carb diet, which I think is the national diet of Sweden now or something, right? It's become the big high fat, low carb diet. It's become the national diet of Sweden. And they do really well. Some people say, I've tried it and I get all the headaches and the works. So some people, as they're transitioning from burning carbohydrates to burning fat, can't handle these side effects. In terms of, to me, muscle is critical, but it doesn't just have to be mass. When you first start using your muscles, you actually increase the number of mitochondria, you increase the metabolic activity, you increase the actin-myosin filaments, you increase their contractility, without necessarily increasing your mass. Only after a certain amount of time do you increase your muscle mass. So it can be, you do increase your muscle mass too, but it can be hard to, the metabolic function of muscle is not just reliant on its mass. But I do say to people, I would suggest interval training and 2 to 3 days of 2 to 3 basic muscle gaining compound exercises, squats, planks and press-ups. And that way you're kind of continuing to trigger that muscle to keep developing.
Thanks. And the other question or the remarks to this problem, because it is a very, the economical problem of the diet, because there is the economical war against the development states, etc.
Any other questions? Yes.
Well, it's not a question, maybe it is a comment. Actually, there is a rationale behind the insulin resistance, because it's a scientific rationale. Actually, the obesity induced by high-fat diet is not a disease. We know that. But when people become obese because of high-fat diet, actually those fat cells release a hormone which is called leptin, and that leptin is activating cytokines in the body, such as TNF-alpha, and these cytokines actually deprive the sensitivity of the insulin receptors.
Yes.
And then the receptors are desensitized, then they don't respond to insulin.
Absolutely.
And that, at this point, it becomes a kind of disorder
cycle.
or disease.
Yeah.
So that's why.
Yeah, so I talked about leptin resistance being genetic, but leptin resistance can also be induced by a poor diet. So that whole leptin resistance, insulin resistance, leptin resistance cycle can be modified through modifications of what you eat, how you eat, when you eat, when you move. Because you can start to improve your insulin sensitivity just through those measures. And then through those measures, you actually end up modulating your own physiology. Yeah. Anyone else? But you're 100% right. And inflammatory cytokines, one of the reasons they think that in Scotland, in Scotland there's a very large amount of heart disease that develops early. And if any Scottish people are here, they can correct me if I'm wrong. The what, sorry? No, I don't. Sorry. What I was saying was, in Scotland, there was a lot of heart disease and diabetes that's developed after about the last 10, 20, 30 years. And what they think is that it's because there was group A strep infection. So there was, group A strep pharyngitis and group A strep kind of infection that went through the whole population. And those who had a very, very active inflammatory system survived. So that, in that environment, if you had a very active immune system, your inflammatory system was able to come along and kill the group A strep, then you survived. Their descendants now have a very inflammatory phenotype, possibly through some of the mechanisms you're talking about. And in the context of diabetes and heart disease and cardiovascular disease, that inflammatory diathesis or phenotype leads to much worse outcomes.
Right.
Yeah.
Absolutely.
There's a question what is the occasion for the leptin increase? It is only during the sleeping and during the night. If you have tried to collect leptin concentration, how to influence there? It's not possible to increase the leptin increase during the sleeping during the day.
Well, it all depends on the number of fat